Observe the different hair colors of people around you. As you can see in this picture, people have different shades of hair. Some have silky hair, others have curly hair. Some have frizzy hair and some have smooth hair. In the same family, children have different hair colors, as you can see in this image, and eye colors from their parents, and also at the same time, similarities can also be seen between children and their parents. And these similarities and variations are due to genetic traits, that is linkage and recombination, that directly affect the physical appearance of living beings. In this video, we are going to know about the linkage and recombination that occurs in the genes present on the chromosome of living beings. Now, let's try to understand various facts and steps of the linkage and recombination process. Humans have 23 pairs of chromosomes, right? It contains hundreds to thousands of genes. And each gene carries the instruction that determine the different features like eye color, hair length, and your weight, and many features. There are different types of genes for every feature. You may think about the true meaning of linkage and recombination and how it is related to chromosomes, genes, and also the relation with variations in phenotype. So let us discuss all these questions in this video. The term chromosomal linkage describes a physical association of genes on a chromosome. The term chromosomal recombination describes the generation of non-parental or new gene combinations. T.H. Morgan and his colleagues described the chromosomal theory of inheritance as genes are located on chromosomes and they look like beads on a string, and some genes are linked together on chromosomes. Morgan and his group also discovered that when genes were grouped on the same chromosomes, some genes were tightly linked on the chromosomes while others were loosely linked. According to Morgan's theory, when genes are found on different chromosomes or at distant on the same chromosome, they assort independently and they are called unlinked genes. When genes are close together on the same chromosome, they are called linked genes. So you know about linked and unlinked genes, right? Hence, we can understand that two close linked genes will have very few chance of recombination and two distant genes will have the more chance of. Morgan carried out several dihybrid crosses in Drosophila to study the sex-linked genes. For example, Morgan hybridized yellow-bodied, white-eyed females with brown-bodied, red-eyed males and intercrossed their F1 progeny. He found that the two genes did not segregate independently of each other and the F2 ratio becomes significantly varied from the 9:3:3:1 ratio. Morgan concluded that genes were present on the X chromosome. When the two genes in a dihybrid cross were situated on the same chromosome, the proportion of the parental gene combination was much higher than the non-parental type. He defines this phenomenon as the physical association of two genes and it is termed as linkage. The term recombination describes the generation of non-parental gene combination. While experimenting, they also found that even when genes were grouped on the same chromosomes, some genes were tightly linked and showed very low recombination, while others were loosely linked and show higher recombination. For example, he found that the genes for the color white and yellow were very tightly linked and showed only 1.3% recombination, while the gene for white and miniature wings showed 37.2% recombination. Now you know about linkage and recombination events that occurs between genes present on the chromosome in living beings or living organisms. Due to the above events, phenotypic variations occur in living beings. How it is useful in further studies like mapping, how the frequency of recombination between gene pairs on the same chromosome can be used for genetic mapping. Let us discuss these questions in next video. Now, let us summarize what we have learned.
Manorama Horizon. Learning made simple.